We are tackling soil classification for the FE Civil exam, focusing on the Unified Soil Classification System, or USCS, and Atterberg Limits. This is a very common topic in the geotechnical engineering section, and the entire process is essentially a flowchart problem using the resources in your NCEES FE reference handbook. The first, most critical step is determining if the soil is coarse-grained or fine-grained. The dividing line is the number 200 sieve. If more than 50% of the material by weight is retained on the number 200 sieve, it's a coarse-grained soil. If 50% or more passes through the number 200 sieve, it's a fine-grained soil. An exam question will almost always start by giving you this percentage. For coarse-grained soils, the next step is to determine if it's a gravel, symbol G, or a sand, symbol S. This depends on the coarse fraction passing the number 4 sieve. If more than half of the coarse fraction is retained on the number 4 sieve, it is a gravel. If half or more passes, it is a sand. After that, you'll determine if the soil is well graded, W, or poorly graded, P, by calculating the coefficient of uniformity, Cu, and the coefficient of curvature, Cc, from the grain size distribution curve data provided. The specific criteria, like Cu being greater than 4, for well-graded gravels are listed in the handbook's tables, so there's no need to memorize them. A very common exam trap involves the percentage of fines. If the soil has less than 5% fines, it's clean, like GW or SP. If it has more than 12% fines, it's dirty, like GM for silty gravel or SC for clay sand. The trick is when the fines are between 5 and 12%, which requires a dual symbol like SP, SM. Expect to see a question testing this specific borderline case. Now, if the soil is fine-grained, we ignore gradation and turn to the Atterberg limits. You will be given the liquid limit, LL, and the plastic limit, PL. The first calculation is the plasticity index, PI, which is simply the liquid limit minus the plastic limit. With the LL and PI values, you go directly to the plasticity chart in the handbook. This chart is your primary tool for classifying fine-grained soils. The x-axis is the liquid limit, and the y-axis is the plasticity index. The chart is divided by two key lines. A diagonal line called the A line separates clays, which plot above it, from silts and organics, which plot below it. A vertical line at an LL of 50 separates low plasticity soils, L, from high plasticity soils, H. For example, a soil with an LL of 40 and a PI of 25 would plot above the A line and to the left of LL equals 50, making it a CL or a lean clay. An exam trap here is to give you values that plot exactly on the A line. In this case, it's classified as a clay. A helpful mnemonic to remember where clays and silts plot is clays are high above the line. This helps you remember that clays, symbol C, are above the A line on the chart. Finally, you might see the AASHTO classification system, which uses groups like A1 to A7 and is mainly for highway subgrades. While it's in the handbook, the USCS is far more common on the FE Civil exam. Know where to find the AASHTO table, but focus your study efforts on mastering the USCS flowchart. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.